Imagine a scenario where you can add complex new features to your application without ever opening the files of your existing working code. That isn't magic. It's the open-closed principle, and it is the single best way to prevent regression bugs in growing software systems. The principle, originally coined by Bertrand Meyer, states that software entities should be open for extension but closed for modification. In plain English, you should be able to change what a module does by adding new code, not by rewriting the old code. Let's look at a common violation. Here is a payment processor class. It accepts a payment type and uses a switch statement. If it's a credit card, do this. If it's PayPal, do that. It works, but it's fragile. Every time the business wants to add a new payment method, say Apple Pay or Bitcoin, you have to open this file and modify this tested class. Why is this bad? Because every time you modify this class to add Bitcoin, you risk accidentally breaking the logic for credit cards. You are touching code that is already working. As your team grows, merge conflicts in this file become a nightmare. We need a way to close this class to modification. To fix this, we rely on abstraction, specifically interfaces or abstract base classes. Instead of the processor knowing about specific types, we create an interface called iPaymentMethod. Now, we move the logic out of the main processor. We create a credit card class that implements the interface. We create a PayPal class that implements the interface. Each class contains its own specific logic. The complexity is now encapsulated within these individual classes, not jammed into one giant switch statement. Here is our refactored processor. Look how clean it is. It simply takes the interface and calls process. We can now say this class is closed. We never have to touch this file again, no matter how many payment methods we add in the future. So, the boss wants crypto payments next week? No problem. You create a new class, crypto payment, implement the interface, and you are done. You have extended the behavior of the application without modifying the existing processor. The existing code remains safe, tested, and untouched. By adhering to the open-closed principle, you achieve three things. You drastically reduce regression bugs. You make unit testing easier because classes are smaller and focused. And finally, you create an architecture that welcomes change rather than fighting against it. This is just one of the solid principles. If you found this breakdown helpful, please leave a like and subscribe. And let me know in the comments, what's the hardest part of applying design patterns in your daily work? Thanks for watching.